The reaction we're going to do now is the preparation of ethylene gas. This involves having ethanol. Ethanol consists of two carbons with an OH bond here. All the whites represent hydrogens. And we're going to turn ethanol into ethene. That's the structure of ethene, and water. What that reaction then involves, if you look on the right hand side, you've got the same molecules as on the left hand side. So we're going to get our ethanol, remove the water molecule from that, and we're left behind with an ethene molecule. Ethene, because it has a double bond, is an unsaturated compound. The reaction apparatus for this is a test tube with a side arm and a very tight-fitting bung. It's imperative a very tight-fitting bung in this particular practical. And then a Bunsen burner for heating the aluminium oxide. And here I've got my glass trough to collect the ethene gas, and I'm going to be collecting the ethene gas in these glass jars here. The chemicals required for this practical are ethanol, which we'll be dehydrating. So I've taken the ethanol here and put it into a squeezy bottle. We will be using aluminium oxide to dehydrate the alcohol. So here's aluminium oxide, and you can see from the petri dish in front of us, it's a white powder, non-transitional metal element. And then the test to see whether we have ethene gas produced are using lime water, acidified potassium permanganate, and bromine water. We also need some glass wool to support the ethanol before we start the dehydration reaction. The first thing in this practical is putting the ethanol into the test tube. So here I have my ethanol in my squeezy bottle. I'm not doing this stoichiometrically, I'm just adding about 25% of the volume of the test tube full of ethanol. That's my ethanol is now being introduced. Now ethanol is now on the inside of this test tube. So what I want to do is make sure that ethanol is removed by putting in my glass wool. That's going to take the ethanol down off the side of the tube, then using your spatula, that's drying the inside of the test tube and supports the alcohol in my tube. Now I want to add my dehydrating catalyst, my aluminium oxide. So I have my aluminium oxide, my white powder aluminium oxide. It's a very finely divided powder. So I put my aluminium oxide on the inside of the test tube, spread it out as much as possible, because the more surface area available, the better the catalytic reaction that happens. So again, I'm not doing this stoichiometrically, I'm just adding in the aluminium oxide in order to create a largest surface area as possible. You may notice I removed the rubber from the clamp because this test tube gets very hot. So in order to stop the rubber from melting, I've actually taken it away. You need a very tight bung in order to stop the ethene gas from escaping. So hold my test tube, I'm going to get that bung as tight as possible. And now my reaction is ready to go. Next part of this reaction is the heating of the aluminium oxide to start dehydrating the ethanol into ethene. So I have my glass jar ready to receive the gas, but the first few bubbles of gas that are produced are going to be the displaced air that's in the test tube and in the rubber tubing will first of all have to be displaced. Once I've displaced all that air, I can then start collecting my ethene gas, and I have my trough and my glass jar ready for catching that particular gas. So next procedure is to light my Bunsen burner. Now we've got our Bunsen burner lit. We're going to start heating the aluminium oxide. Notice I'm heating the aluminium oxide and not the ethanol. And we can already see bubbles of gas coming out of the tube. That is not product, that is displaced air. So let that happen for a while. And once we've decided we've got the volume of gas, then we can start to collect our gas. At this stage, we will have ethene gas coming out of the tube. So put it into my beehive and then put my glass jar on top of the beehive, and we can see bubbles of gas going into the glass jar. That's ethene gas is now being collected. While our glass jar is filling of ethene gas, we'll prepare the test for the unsaturation. Two tests for unsaturation are bubbling the solution through bromine water. I'm going to fill two test tubes full of bromine water. One can act as the control, one we can test. And likewise, I have acidified potassium permanganate. I'll fill two test tubes again. One the test tube we're going to do the experiment on, and one is the control. We will now bubble the ethene gas through the acidified potassium permanganate. And if we have an unsaturated gas, we should notice the potassium permanganate is decolorizing. So you see the gas bubbles bubbling through, and then when you compare that to control, we can see decolorization has occurred, therefore proving it's an unsaturated compound. The second test for desaturation is the decolorization of bromine water. So here I have my solution of bromine water, and I'm going to bubble the ethene gas through the bromine water, and the bromine is adding across the double bond, so decolorizing the solution. So if we compare that test tube to the control, we can see decolorization has occurred, so proving we produced an unsaturated gas. I've now collected the ethene gas in the glass jar. I can remove the glass jar and put the cover slip underneath it, and we're going to be doing the flame test to see that we've got ethene gas produced. It's very important at this stage to remove the rubber tubing before you remove the Bunsen burner. If you remove the Bunsen burner first, what happens is the gases inside the test tube contract, so causing a vacuum inside the apparatus, drawing the water from the rubber tubing into the test tube, and the test tube can shatter. So the test for ethene gas is it burns with a bright luminescent flame. So always light your lighter before you remove the cover slip, and then light the gas, and we'll notice it's burning with a bright luminescent flame. The byproduct of the reaction will be carbon dioxide. In order to check for the presence of carbon dioxide, I'm going to add some lime water into the container, and if there's carbon dioxide present, the lime water will turn milky. So shake this up, and we should notice how the lime water is turning milky. And just to show that milkiness, I will decant that into a test tube so you can see the milky colour of the lime water, so proving the presence of carbon dioxide.